相关的经验。那么5G 行业网络的这个工作组呢，重点是面向千行百业以场景驱动来推动5G 行业技术的创新，包括最近也是非常热的无源物联技术，以及行业特别需要的确定性网络、通感的融合呀、AI 加物联网大数据能力等等。那么同时呢，也会不断的输出面向行业所需要的解决方案，包括我们5G 的专网频率怎么来实现，怎么样来推动5G 进入行业的时候呢，也能有成功的商业模式。当然，我们会加强国际之间的合作。那么第4个重要的这个我GTI 的工作就是 5G A 和 AI 的融合发展。那么我们希望通过3大核心任务一个是打造开放的实验室，建立开放的协同创新社区，以及挖掘创新应用的案例，来推动5G A 与 AI 的融通发展。那么具体呢，会在4个方面包括我们网络本身的智能化发展，以及我们如何用这种数字孪生技术结合 AI 来推动5G 网络的这个高效高智能化的发展。同时呢，我们前面可以说是 AI for Network， 那么后面呢，我们会考虑怎么更多呢用 Network for AI， 就是说我们未来的5G 怎么赋能 AI 的这个发展，那么以及通过 AI 来推动5G 的可持续发展。那么在5G A 乘 AI 的这个开放实验室的这个工作呢，得到了产业的大力的支持。我们目前呢，已经在中国，像这个北京上海还有像我们在一些地区已经建设了这个5G 乘 AI 的开放实验室，得到了像这个华为、中兴的这个支持。我们也很高兴的看到在海外也有，在爱立信的支持下呢，我们在斯德哥尔摩建立了开放实验室，在 Intel 的支持下呢，也在像美国墨西哥州等等建立了这个开放实验室。同时呢，我们跟 GTI 也共同利用我们的这个开放协同创新的社区。我们这个社区呢，是大家共享交流5G 乘 AI 的一些技术方案、一些经验的一个社区。同时呢，我们也希望通过这社区呢，把产业在推进5G A 乘 AI 发展中的一些关键问题，我们叫做 challenge 给它这挑战，就是挑战的这么一个任务发放出来，欢迎全球的合作伙伴来攻关。那么对于这个攻关的成果，我们会推广和应用，当然也会给予一定资金的支持。所以我们今年我们跟 GTI 呢已经发布了2个这个挑战，一个是全球很多重要频段的一个统一划分。那么面向未来，我们也希望进一步推动5G A 演进过程中，怎么能够更好的使用频谱来支持多样场景的这个应用，包括工专怎么样结合，地面和低空怎么结合，甚至将来跟卫星我们怎么样来共享频率。那么面向未来的6G 我们现在也要未雨绸缪，来开展考虑规划面向6G 的。那在全球世界移动通信大会这么重要的一个场合呢，我们也会有 GTI 的产业峰会和我们的工作组工作的研讨会。那么在明年的6月份，也是上海的这个全球移动通信大会上，也有我们 GTI 的产业大会。同时呢，我们会在香港以及海外的一些地区召开我们的 GTI 的这个就是工作的研讨会以及频谱技术研讨会。那么当然具体呢，我们还会跟大家协商到底什么时候在哪些地方。初步考虑呢，明年我们会拓展向行业的专网的解决方案，同时呢会发布一系列的 GTI 的这个技术白皮书和这个标杆案例成果。在这个会场的外面，我们也有一个小的展示区 也把很多重要的这个面向 5G 低成本网络建设以及新型的5G-A 的技术，还有像无源物联技术等等，给大家进行展示，也欢迎大家去参观交流。这个是 GTI 一向要作为一个组织我们公开讨论的时候呢，有一个这么个声明吧，就是说在这个会上讨论的内容呢，都是可以公开的。最后呢，也请大家这个扫一扫 GTI 的我们线上的这个平台。我们不仅仅有这样的产业的研讨会，我们更希望在日常中通过这种线上的平台跟大家交流、互动和合作。那么这里面包括这个WhatsApp， 包括这个 Twitter、YouTube、LinkedIn 所以也很方便我们全球在不同国家和地区的产业伙伴们共同加入到 GTI 平台来进行交流合作，促进全球
evolution part, spectrum and technology, and we welcomed our speakers, appreciate their presence here, their participation and collaboration. I also was interested in the QR codes that Madam Huang showed. I think we have an open collaborative spirit that we should join and grow together. With that, allow me to invite the first speaker, Mr. Li. Thank you.
我介绍一下5G 我国的5G 技术的大概的发展的路线。那首先呢是发展的基础阶段，是从这个2019年开始，以这个3GPP 的 R15和 R16版本为基础呢，主要提供了这个我们的增强移动宽带 eMBB 的这样的业务。那第二个阶段呢是从这个2023年开始，那么进入到5G 的增强阶段，这个呢以3GPP 的 R17版本为基础。那主要提供这个5G 的轻量化的业务，就是那个 RedCap 这些业务。那么目前呢，我们现在就进入到了5G 的这样的一个演进阶段。那从这个2025年开始，我们将这个以那个5G 的 R18和 R19版本为基础，那么主要是对应刚才各位领导提到的这个5G-A 阶段着力呢去提升这个5G 的性能，重点呢是开展呢对通感一体，包括人工智能 AI。还有呢，对地面非地面网络 NTN 的场景的各个场景的这个支持。刚才呢，各位领导呢也都提到了，无线频谱呢是5G 网络运营的核心资源。那中国政府呢，通过科学规划和合理分配频谱资源，为5G 网络的建设呢提供了基础的支持。那这里呢，我把那个我国的这个公众移动频率的这样的一个分布的情况呢，做了一个简单的展示。然后呢，我也把这个可以单独部署和那个融合部署5G 的频率呢，也给大家做了一个展示。我们可以看到，相应的频率呢还是非常的丰富的。那总体上来看呢，我们的频谱的总体方案与全球的主流的规划是相兼容的，有利于共享全球的这样的一个产业基础。那么可以看到，国家无线电管理机构呢，我们是付出了很大的努力，为这个公众移动的建设呢，争取了海量的资源。为保障呢我国5G 的网络的平稳建设呢，也是付出了极大的努力。下面呢是在那个我国呢，在5G 工业专网领域呢，我们通信方面呢，也积极的推进了相关的频率的规划和网络的建设的工作。那么2022年呢，我国呢向这个上海商飞发放了企业5G 专网的频率许可。那么主要是有2段，一段呢是6G 频段的5925到6125兆赫兹，另外一个呢是毫米波频段的24.75到呢25.15 G 赫兹。那么根据这个最新的这个数据显示我国的5G 加工业互联网全国的建设项目呢超过了1.5万个。 实现了41个工业大类的全覆盖，在这个各行业各领域的应用呢，带动了制造业的高端化、智能化、绿色化的发展。预计呢，到2025年，全球的5G 工业互联网市场规模呢，将达到数十万亿元，这个显示出这个非常巨大的市场的潜力。那下面呢，我也是列举了几个国内的比较好的5G 工业互联网的一些项目。那这些应用案例中啊，相应的企业的整体这个智能化水平呢，都得到了极大的提高，生产效率和经济效益呢，都有明显的增长，取得了很好的应用示范的效果。那这里刚才也包括了商飞啊，还有这个宝钢等这些企业，应用效果都非常好。那么综上所述呢，可以看到，我国呢在5G 网络建设方面还是取得了良好的成果。据统计呢，我国累计建设5G 基站总数啊，达到了383.7万个，占全球5G 基站总数的60%。5G 用户数呢，占到了全国移动通信用户数的50%以上。5G 应用案例呢，累计超过了9.4万个，在工业、矿业、电力等行业呢，已经实现了规模化的应用。刚才也提到了 GSMA 发布了中国的移动通信经济发展2024报告，在这个报告里预测呢，到今年年底，中国的5G 连接数呢将突破10亿大关，成为全球最大的移动通信市场。预计呢，到2030年，中国的5G 连接呢将占全球总数的近1/3。这些成果的取得呢，都离不开中国政府在频谱资源方面上的大力的支持，还有大规模的投入。下面呢，我将简要的介绍一下我国5G 频谱的规划的相关政策。那5G 业务发展呢，对这个频率资源呢的需求呢是十分迫切的。刚才呢，各位领导在提的过程中也提到了。那无论是在这个公众移动通信，还是在这个工业互联网方面，频谱规划呢所面临的挑战呢都是很大的。那么具体的挑战和需求呢，大家都知道啊，那我就不再详述了。那工业互联网这个工信部呢，从这个2009年开始呢，就陆续发布了相关的政策文件，包括呢频谱分配、技术要求，还有干扰协调管理、共建共享等方面。那这些呢，都体现了我国在推动5G 发展方面的全面布局和这个细致规划。那整体来讲呢，我国的5G 频谱规划呢，主要有5个出发点。那这里呢，我也简单的列举了一下。那么第一个呢，就是我们的这个频率，要明确我们的频率配置策略。那第二个呢，就是要加强中频段的干扰排除。那么第三个呢，就是要释放低频段的这个宝贵的这样的频率资源。那么第四呢，刚才也提到，就是我们的毫米波啊，要推动我们整个的毫米波的应用。然后后面呢，是要建立这个频率的共建共享的这样的一个方法。那下面呢，我想简单的吧，每一点呢都简单介绍一下。第一个呢，就是明确频率配置的策略，充分考虑到产业发展和频率使用的现状，明确呢5G 优先配置中低频段，适时呢配置高频段的这个策略，满足不同场景下网络的需求，实现呢低中高频率协同发展，筑牢呢5G 6G 的发展基础。那这里呢，我简单的把几个，因为确实太多了，我也没法那个都列上。那么把最新的几个吧，23年和20年相关的这个部署呢放在这儿，那么大家可以简单的看一下。那么2呢是开展这个5G 中频段的干扰排除的工作。那中频段呢，刚才也提到了，我们部署了很多，而且未来发展也很好。那中频段布置5G 系统呢，可能呢会对同频段的或者3个呢就是释放低频段的频谱资源。为了增强低频段频谱的配置，中国无线电管理机构呢，从这个2010年开始就在推动这个数字红利释放工作。从这个2020年的发布了相应的规划，将那个刚才就是这边我们写到这个文件里看到的啊，将这个702到798兆频段呢用于调整这个规划呢，计算做了调整，用于这个移动通信的这样的一个系统。 然后呢，为这个5G 的发展呢提供了极其宝贵的低频段频谱的储备，那将有效地满足垂直应用领域5G 应用的海量设备连接的这样一些需求。在这块呢，工信部这边呢也做了极大的协调，因为毕竟还是跨这个管理部门嘛，需要协调的资源还是非常的多的。那么第4呢是推动毫米波的应用，着手5G 毫米波频率的规划，在国内前期协调的前提下呢，尽快开展毫米波频率规划，将有利于提早稳定产业的预期。国家无线电管理机构呢，积极开展这个毫米波的电磁兼容分析、候选频段的意见征集和这个技术研发试验，对我国微波通信系统频率使用规划呢进行了优化调整，以满足5G 基站等高容量信息传输场景的需求，并为我国5G 工业互联网以及未来6G 预留了频谱资源，推动我国微波通信产业的高质量发展，并为5G 工业互联网以及未来6G 的技术发展提供这个频谱资源的支持。这个就是刚才提到的这个我们整体的这样一个规划。5呢是创建频率共享的办法，发布了5G 移动通信系统无线电频率共享管理办法，鼓励国内基础电信运营商企业开展5G 共建共享，提高公众移动通信频率的使用效率和综合效益，确保企业呢在5G 共建共享中依法合规使用频率资源，降低了企业的运营成本和负担，促进了5G 网络的建设和推广。下面呢，我对这个未来中国5G 的频谱的发展呢，做一些个人的展望。第一个呢是促进6G 中频段频谱的使用。6G 赫兹呢可以兼顾低频率的覆盖优势和高频率的这个容量优势，达到这个覆盖和容量的良好均衡。该频段的使用呢，有望呢大幅度提高网络的容量和速度，助力移动运营商增强网络连接的普遍覆盖，同时呢，也将满足智慧城市、智慧交通和智慧工厂所需的高速传输和这个大容量的需求。当然呢，在发放这个6G 频段使用许可之前呢，我们还有大量的这个相关的工作还是要做的，其中呢包括研究这个6G 赫兹频段不同系统之间的兼容共存条件。还有呢，为了实现全球的漫游和跨国界的无缝服务而进行的国际频谱协调，还要激励那个制造商生产支持6G 赫兹的这个设备，发展成熟的设备生态系统等这些工作啊。这刚才我们在交流的时候也提到了这些内容。那再下来一个呢，就是未来发展的一个很重要的一个方面啊，就是推动5G 毫米波频谱的开发利用。那工业互联网呢，是未来5G 发展的重点方向，要加快落实推进5G 毫米波频谱的应用，做好5G 毫米波频谱的开发利用和技术创新实验工作，满足大型、特大型企业的个性化网络需求，稳步推进工业5G 独立专网的试点工作，明确试验的区域、试验的内容，还有试验的规模等等这些信息。后面呢，这个相应的无线电管理机构呢，也还要做好这个整个的统筹和评估工作，还要做好这个监督和总结，那个为未来的这个毫米波的发展呢做好那个基础。那么呢，以上呢就是我的一些分享。那么感谢大家，欢迎批评指正。
Guests, I'm excited to share with you our views on how spectrum can help us for the benefit of billions of people. I'm Liu Hong, the head of technology for Great China in GSMA. Currently, as we move into the next phase of 5G, we are looking at significant advancements that will further enhance the speed, the global coverage, the mobility, and power efficiency. These improvements will support new use cases and ensure that 5G reaches virtually all devices and all developments involving connectivity. The next of 5G, often referred as 5G Advanced, brings a host of new capabilities that will revolutionize the way we interact with technology, such as AI. And it also strengthens the foundation of the 5G system by improving uplink and downlink speed, by extending the global coverage to forests, deserts, oceans, and skies. That the allocated low band and mid-band spectrum resources vary from country to country. Thus, developing a comprehensive spectrum roadmap globally is significantly important to guide the planning process of all countries and ensure that spectrum is made available to support the next phase of 5G development. The WRC-23 has opened the doors to a new era of connectivity for all services and laid the foundation for mobile progress into 5G Advanced. The GSMA believes that no one should be left behind in the digital age. And the decision of WRC-23 will allow us to deliver a brighter future where mobile brings communications and mobile delivers industry applications, and mobile provides economic growth. Implementation of the following WRC-23 decisions will support global digital ambitions. Deliver greater digital, not be dependent on where a person lives. And progress on low-band spectrum will help to ensure that digital equality is achieved between urban and rural areas. And the second decision is about harmonization in 3.5 gigahertz, mainly the 3.3 to 3.8 gigahertz. Because 3.5 gigahertz is recognized as the pioneer of 5G band. It is already assigned in over 80 countries. And the further harmonization of this band at MWC-23 will allow more countries to take advantages of economies of scale in the mobile development and benefit from higher speed provided by wider spectrum channels in this range. The third decision is about expansion. This is one of the most significant outcomes of WRC-23. That is the identification of 6 gigahertz, the additional mid-band spectrum to meet the growing demand. The band between 6.425 gigahertz to 7.125 gigahertz was identified by countries in every ITO region, including the EMEA, Americas, and APEC. It is supported by countries representing over 6% of population of the world. It is now the harmonized home for expanding mobile capacity for 5G advanced. The decision also serves as a critical trigger for the development of 6 GHz ecosystem. According to our research, 5G is expected to yield more than 961 billion in additional dollars in additional GDP value added to global economy. Mid-band actually represents more than 63% of this value. However, the results are based on the assumption that the regulator will make mid-band spectrum available in a timely and affordable manner. The 5G consumer experience, it impacts the 5G consumer experience, it impacts the download and upload speed. The global economy, in that case, could lose up to 40% of the expected 5G benefits. So in such a scenario, global 5G benefits in 2030 could decrease to less than 600 billion, less than $600 billion in that case. This is the current 5G network launches by frequencies. You can find out that mid-band spectrum, especially the 3.5 GHz band, dominates the 5G network launches. It accounts for nearly 47% of 5G network launches. The importance of mid-band spectrum cannot be overstated, as it provides the necessity of bandwidth to support not only the high speed, but also the high capacity of 5G network with very good coverage. Six GHz is the last opportunity to obtain a significant continuous mid-band spectrum today. With the decision made upon the upper 6 GHz band in IMT at WRC 23, the 6 GHz timeline now is clear. National regulatory authorities are now placing the band in their national tables of allocation and start considering making the band available to mobile operators. The trials of 6 GHz network equipment, as you can see that starting from 2 years ago, now occurs across the world in many countries before and after MWC 23. And operators and vendors now have a common view that 6 GHz will scale in a time frame from 2025 to 2030. And the products will be available worldwide in a time frame of 2024 to 2025. The GSMA, together with its stakeholders in the picture showed, we call on a government and the industry to work together to support the full development of 6 GHz development band, which include to support the full development of 6 GHz for mobile, to ensure the spectrum roadmap is delivered for mobile operators, and to put in place clear timelines for equipment and handsets to be ready to scale. As we know from the past, the spectrum, including but not limited to 6 GHz, should be made available at the right time, under the right condition, and in sufficient quantity at the right price. We also recently did 2 best practice case studies together with China, one on voluntary spectrum and infrastructure sharing, and the other one on 6 GHz. Those best practice, including developing a spectrum roadmap, including ensuring the service and technology neutrality, and coordinating cross-border spectrum use, and setting conservative prices to support long-term sustainability. So in conclusion, by focusing on enabling network technologies, addressing spectrum needs with appropriate spectrum such as 6 GHz, by adopting the best practice for spectrum policy, we can ensure that 5G continue to drive economic growth and improve the quality of lives for billions of people around the world. Thank you.
Thank you very much. We appreciate your being here. We also appreciate our partnership with GSMA and congratulate and applaud your fundamental principles. I think it's very important as an international global alliance to have such guiding principles as a global harmonization, inclusion, equality, and expansion. Thank you. Now, in our great agenda with distinguished speakers, next we have talks from industry and academia, and no surprise that we have good speakers next from Nokia and Ericsson. First, Mr. Chang from Nokia. Thank you.
So I believe it's a fair proposal that I deliver my speech in Chinese with slides in English, right? I hope this works. 尊敬的高主席、各位领导、各位嘉宾，早上好！非常高兴能再一次来到 GTI 的 workshop。那我今天呢也是跟大家分享一下诺基亚在6G 频谱上的一些思考和策略，也是希望能够在线下大家一起多多交流和讨论。其实我拿这张片子做开头是有深意的，这是我今年在珠海航展拍的比较满意的一张照片。我为什么放在这儿呢？因为我们知道工欲善其事，必先利其器，其中频率就是最重要的一个大器。这个大器要做到的话，一定需要行业各方面大家紧密的协同，就像飞行表演一样，大家每一架飞机目的地可能不一样，可能都有不同的颜色，但是为完成统一的一个事业。精密配合，紧密协同，这就是我们今天在频率推动方面要做的工作。那这个路线图，我相信在座的人都非常的熟悉啊，我就不展开讲了。关键一点就是，我们现在整个产业，包括我们的 industry， 包括我们的 regulator， 我们的客户，都有一个共同的认识。这个认识的基础是我们推进频率分配、频率的工作的一个坚实的一个保障。 那我们需要注意的就几个关键的节点啊，包括已经过去的 WAC23。那在未来我们可以看到 ，ITU 会按照它既有的节奏，包括 IMT2030的 workshop 在2027年，包括 WAC27，也是恰恰在6G 商用之前非常重要一次频率的决策会议。那从 3GPP 角度来说，我们所做的每一步工作也是匹配整个监管和行业发展，整个的这个生态，大家是围绕着一个共同的目标再向前前进。那如果从6G 的第一天，我们叫 Day One 的 focus， 就是6G 的 readiness。从多家的观点，我们认为有这6个主要的技术创新领域，非常大规模的继续大规模天线的这个部署，去不断的提升这个网络的能力和容量。我们的平滑演进如何确保核心网络和网络架构的统一，包括我们可持续发展，对吧？这个节能的6G 的节能的新的技术，以及我们可编程网络以及开放的 API， 确保网络变现的能力和扩大繁荣生态的发展。同时也包括我们 AI 的内生，如何用 AI 去赋能我们未来的网络，不断提升网络的智慧和打造网络自动化。当然了，也包括我们空天地一体通信的这个愿景。所有的这些关键技术结合在一起，也就给我们带来了不一样的第一天的用户的这个 user case。那如果把整个6G 的关键技术摆在一个视图里边，我们看到主要是2个点，一个是我们要 balance reuse 的能力，包括我们前代的技术，包括对未来6G 创新突破带来的新的价值增长。这里边包括新的频谱非常关键，这是确保6G 能够实现它的愿景，能够以足够的资源来确保达到6G 的这个。基本上我们从诺基亚的角度，我们放了3个典型的用户案例或者 user case， 一个是增强现实 extended reality， 还有全息通信，对吧？包括我们通感一体。如果把这3个主要的6G 突破创新的用户场景摆在一起，我们看到确实基于今天频谱的需求来说，我们需要更多的频谱。那总体来说，我们需要增加 1.5G 到2G 赫兹的新频谱，尤其是在15G 赫兹以下，来确保至少这3大重要的场景能够在未来有一个充分和全面的发展。那今天我们问自己，为什么6G 的频谱制定频谱讨论现在就要开始？其实我们从3G、4G、5G 整个历史发展当中汲取了很多有益的经验，当然也有教训。那最终我们看到，在6个方面告诉我们，今天6G 频谱的讨论和推进势在必行，必须要从今天开始。那第一，现有的频率资源无法支撑未来6G 给我们带来的广阔的容量的需求。那从现在在一些特殊频段的这个监管的确定来说，能够尽快的确定频段，能够推动产业在一些特有频率里边的投入或者投资的决心。那从整个生态和未来6G 的经济规模来看，当然我们需要更多新的 plan， 大家就会深刻的感受到这个频率的碎片化，在6G 第一阶段我们就要把它规避掉。当然也包括我们有新的频率，一定会带来新的行业进入者，他们能够有决心在这个行业持续去投资，共同繁荣6G 未来的产业。所以如果摆到WRC23这个时间点，我们看一下，那从频率的分层来看，那今天我们6425到7225在 WRC23基本上已经确定。那从诺基亚的观点来看，我们认为有更多的频段我们需要去加以关注包括像14.8到15.35这个15G 左右，包括7.125到8.4G 的这个，能够给我们提供大概1700兆赫兹这样的一个频带。我们是在推动能够在 WRC27作为一个研究，继续产业之间形成共识。当然也包括低频的这种覆盖频段470到690呢，会继续推进这个对未来在整个产业生态的繁荣和这个广度都是非常重要的。那简单的把几个频段打开来看一下6.4到7.1、7.1到8.4，其实6425、7025今天已经被确认 IMT 的用户，对吧？在很多的国家当中，其中7025和7125在 Region 1和 Region 3也被确立是 IMT， 在一些 Region 2的国家里也被确定是 IMT 的用途。那当前我们重要的一个任务就是什么？确定7G 赫兹的频谱，它的覆盖效率 是不是能达到一个高效和经济的规模。那其实诺基亚也在前期啊，在我们芬兰做了这样的一个外场实验，就是把7G 赫兹和3.5G 赫兹的天线放在一起去做整个覆盖的评估。所以从我们的角度来看，确认7到8G 赫兹的这个频率的覆盖啊，有巨大的潜力。那我们做了一些实验，这是一些实验的结果啊。其实从这个图大家可以看到，7G 赫兹，我在6G boost 的这个基本空口的这个使能下面，我可以达到 suburban 的情况下达到0.98的cell range， 对吧？这个基本上跟3.5已经在Appendix 30B 作为 FFS 的用户 ，FSS 的用户啊，全球都有计划。FFS 的用户啊，全球都有计划。那从我们既往的工作经验来说，我们移动通信产业从来不怕做共存研究啊。我知道我在职业生涯中做了无数的共存研究，所以在3600、3800之前，我们在 WAC23 Agenda Item 1.2做过这样共存研究啊，跟固定的卫星通讯。那我们认为，在4800、4900，包括4900到4800到4990这个频率段啊，需要去加强我们研究和部署的能力，同时做好这个相关的共存的研究。这块我们认为是未来在这个工业领域里以及企业级无线专网的领域里具有非常大的潜力。那14.8到15.3呢，现在也都明确的有用途啊。从现在的角度来看，我们WPP5D 还没有做过相关的地面业务在这个频率里 ，MT 地面业务在这个频率的特征研究，所以我们认为现在是一个非常重要的时间点，我们需要去集聚我们产业的力量，去确立这些合适的评估参数，包括我们的基站和用户端。在这个频率上，我们认为，尤其是在未来这种密集的高容量需求的地点的覆盖是特别有潜力和作用的。所以回到最后呢，作为诺基亚来说，也是一直在跟我们整个产业的各方啊，我们的合作伙伴全力以赴在推进6G 频率的相关的工作的开展，包括我们在6G 的一些前锋或者先锋的频率上，加强跟监管及其他各方的这种交流融合。同时，针对WAC23已经达成的一致的意见啊，我们也在加速和产业一起做相关的评估工作，尽早的要确定这方面频率的可使用以及使用的一些规则。那面向 RC27啊，其实也是一个非常重要的时间窗口，我们要确保面向未来的这3年里，我们能够进一步提早行动，去做好另外的一些高质量或者说有更大潜力的频段的一些研究工作，推动产业尽早的达成共识，同时协同我们的监管各方，能够在这些频率的新的领域里，尽早的明确6G 的 RMT 的使用，也确保我们整个生态啊能有一个非常重要的信心的保障，包括未来产业发展方向性的指导，对6G 的发展啊至关重要。好，我的介绍到此，谢谢大家。
Thank you very much, Mr. Chang. I appreciate those insights and your being here, your partnership and contributions. Now, without further ado, it's also my pleasure to invite Mr. Wang to join us from Ericsson.
Good morning. I'm Tony Wang from Ericsson China. It's my great honor and pleasure to be here to share with you about Ericsson consideration on the future mid-band spectrum opportunity. First, let's have a quick glance at the 5G progress and Ericsson forecast for the later years. According to Ericsson Mobility Report in this year, in June 2024, the 5G had reached 1.9 billion subscriptions in the second quarter of 2024. According some measurement from leading operators on the 5G mid-band spectrum, 97% user activities could achieve better time to content performance of less than 1.5 seconds. So later I will share more detailed data about this test in later slide. If we turn to next 5 years, based on our forecast, 5G will be the dominant traffic in 2028. In 2029, the 5G mobile traffic will increase to 1.9 times of 2023. How to meet the growth of 5G traffic growth is a topic operator have to consider. So if we have a further look at the subscription rising, the 5G subscription is rising in every regions. I don't want to go through all the numbers in this page. Among those figures, I'd like to highlight the 5G penetration in India, Nepal, Bhutan, Southeast Asia, and Oceania. In these regions, the 5G penetration will increase very rapidly by 6 or 8 times of 2023. For Northeast Asia region, due to the very early 5G deployment and the quick expansion of the 5G network, the 5G penetration rate has reached quite high level. It will keep growing up to 2029. The 5G penetration in this region will be expected to be very significant. Predicted traffic growth of the up to 2029 include assumptions that initial uptake of XR type devices will happen in the later part of the forecast period. Globally, the growth in the mobile data traffic per smartphone can be attributed in 3 main drivers. The first is the improvement of the device capability. The second is the data intensive increase in the data-intensive content. And the last one is a continued improvement of the network performance. So it is encouraging that the smartphone shipment growth is back after nearly 3 years decline, increased with a year-on-year increase of 6% from the first quarter of 2024. Oh, sorry. This is maybe the old version of the slide. We missed a page. So as I mentioned previously, here I'd like to want to introduce some more data from the live network. As I mentioned before, we had some study by Ericsson Smartphone Labs. We set up a relationship between the throughput sample at the click with the correspondent time to content performance. So based on our measurement from leading operators live network, we noticed that 97% of the user activities on 5G midband could achieve the very good time to content with 1.5 seconds. Whereas on the 5G low band, only 67% of the subscribers' activities can achieve the same. On 4G network, the result is 38%. So this result demonstrated the great user experience boost with 5G compared to 4G. The operators, the midband of 5G can get a very good balance between the capacity and the coverage. The operator, if the operator aggregates their mid-band carrier with and the existing low-band carrier, they can extend the mid-band coverage, well as to offload the low-band also. So they can promote the user experience in both spectrum band. So that's why we noticed that a lot of leading operators are deploying 5G mid-band nationwide to ensure the consistently great user experience. So this page is a GSMA study for MT spectrum demand forecast. They estimated the mid-band spectrum needs in 2025 to 2030 using different market assumptions for traffic demand, such as highlight traffic cities like Paris, and also some other low traffic cities. The results show that 1 to 2 gigahertz additional spectrum needed from 2025 to 2030 depend on different markets. The additional mid-band spectrum needed over time to address the future capacity need. This is the current situation in the APAC region regarding the mid-band spectrum status, including the current allocation and also estimated available spectrum in 3 years. However, the gap between this projected spectrum availability and the GSMA calculated spectrum require for 2025, there is some big gap between the calculation. The initial uptake of XR type services, including AR, VR, and also mixed reality, will happen in the time frame from 2025 to 2030. That's why we believe an average of 2 gigahertz of mid-band spectrum is needed in the time frame to deliver MT 2020 data rate across cities in an economically feasible manner. So how to address the gap? The available spectrum in 3 gigahertz, 4 gigahertz, and especially 6.425 to 7.125 gigahertz is very important in short term, just like Mr. Chang Yang had mentioned in last presentation. Noting that a larger number of countries identified or wanted to identify 6.425 and to 7.125 gigahertz for MT in WRC 23. We see great momentum of this band to be a global harmonized mid-band spectrum for MT. Ericsson is fully committed to deliver our product in this band. We also driving the follow-up work after WRC 23. For example, in 3PP, we are defining the test methodology to ensure the ARP mask defined at WRC 23 could be tested. The expected finalization of this work could be December this year. All these efforts are aimed at preparing for the creation of the ecosystem for mid-band. So for the midterm, beyond 2030, the spectrum demand will come from not only from the 5G expansion and also the 6G starting. New spectrum like lifeblood for radio innovation, just like Madam Huang had mentioned this morning. 6G will introduce new use cases, and for each new generation or expansion of the user of the existing generations will require sufficient spectrum for its implementation. Ericsson believes additional 1.5 to 2.2 gigahertz of wide area spectrum will be needed, depending on the existing mid-band spectrum available in the countries. The gap could be resolved with a band of 7.15 to 8.4 gigahertz. And WRC MT identification for WRC 27. So let's have a look at the entire picture of the multi-layer spectrum cake beyond 2030 for 6G. So far, no spectrum had yet been formally allocated to 6G, but the discussion had already started in WRC. We believe that 6G shall be able to operate over the entire spectrum range from the sub-gigahertz to beyond 100 gigahertz, including first is the current 5G spectrum. This is needed for 6G coverage and the smoothly migration from 5G. So we will need spectrum sharing with legacy 5G network. The second is a new spectrum in the centimetric range. The candidate is 7 to 24 gigahertz. Of course, we prefer to the 7 to 10 gigahertz. The lower, the better. The third is spectrum in sub-terahertz. This is used for the extreme data rate in inch scenarios. So, as a conclusion, make it mid-band spectrum available in the countries. So that's all for today. Thank you. In the countries. So that's all for today. Thank you.
Thank you, Mr. Wang. Appreciate your being here and your collaborations and contributions. We are pleased that we have Professor Cha from University of Malaya to join us. Appreciate your presence.
Good morning, everyone. I'm Ling. I'm from University Malaysia. So thank you very much for giving me this opportunity to come and speak to you. Now, this is a project in between University Malaya, China Mobile, and also this Digital National Berhad. DNB is our 5G provider in Malaysia. I would like to discuss and talk to you about our initiative of the 5G plus AI Joint Innovation Laboratory. Now, I would like to inform you also that this is an open lab, so we are very open for anyone who like to actually participate and to actually come to discuss with us as well. Now, okay, this is not important. Okay, we are the top university in Malaysia. Currently, we rank number 60 in the world. Then I'm sure you know about this China Mobile, correct? There is the top global telecommunication company. So in this project, we also got the support from this DNB, which is the first provider, 5G provider, and this is a government entity in Malaysia. Now, why are we doing such a thing? Because we have a problems, and I'm here today. I'm also hoping that you may come and also help us to solve some of these problems. We have a running 5G network for about 3 to 4 years, but we have very, very little of industry application 5G going on in Malaysia. So if you look at the situation in Malaysia, we really need a lot of support, especially in the industry applications in Malaysia for 5G. So Now, the missions and the purpose of these innovation labs, they are threefold: academic research, teaching, and also the industry. So at this moment, we are also in the talk and process of having collaboration with the university from China to actually collaborate together in these projects. So we will also utilize the lab for teaching purposes, especially in these wireless environments, network environments, and also the future of wireless network environments. Now, we are so happy that this China Mobile came in and actually helped us to link us with the industry. So this is something that we are looking forward. And we also hope every one of you, you can participate and come to talk to us. This can be a very good entry point for you if you want to also market some of your things in Malaysia and also do or test out your products in Malaysia environments. Now, so what are the actual things that we are looking forward? Now, firstly is about the open labs. So we have the platform, we have the environments, and we actually invite every one of you to come into these environments. We already have a few companies talking to us, including some satellite data, some universities talking about how can we collaborate together and work together. For last few months, when I visited some of the China Mobile supported factories and your 5G environment, we are so impressed with the industry applications using 5G in China. But this can't be seen easily in the Malaysia environments. So we are hoping that more and more participants, especially from China, will come to us and then make us as an entry to see that there is a chop saying that this is GTI certified, right? So we really certified, right? So we really hope that one fine day, maybe GTI can have a meeting in Malaysia as well. And we would like to actually invite all of you to visit the lab and to our university as well. Thank you very much.
Professor. Thank you very much, Professor, and thanks for your collaborations and contributions. And I hope that expands, especially when you talk about industry applications. We also have more of that tomorrow in our presentations. So without further ado, David from Siemens. Thank you.
Good day, ladies and gentlemen. I like to keep it short and easy, so if you later want to reach out to me, just go by my first name, David. I am the head of the strategic product management here in China, responsible for local products and also local for global products. I do understand that I do understand that I'm in the way for your well-deserved lunch break. However, I would like to shortly have a quick story which happened to me after I arrived yesterday. When my plane landed here, my wife called me just to make sure that everything is safe, and we had a little bit talk, and then she told me she's already ordering online. My wife does this very frequently. She enjoys it to buy from the huge available online shops here in China, and when I'm traveling, this is a way how she sometimes spends the time. This one. Okay, thank you. Why I'm telling you this? Because when I was talking to her last night, I discovered that there are actually a few things happening when she's placing the order, and I found it very interesting to think about what is actually happening there, especially with regards to today's presentation. So in my mind, there was a picture created which looks a little bit like this. You see here, it's more or less a vision of a 5G factory warehouse. But within this vision, you have a lot of applications and scenarios, puzzle pieces which work out together. Place now AGVs in order to get the packages picked up and get it ready for transport. My wife is a heavy shopper, so one AGV is not enough, 2 AGVs is not enough. We need many AGVs. And if we do have many AGVs, we want to have it engineered very fast and repeatable. We want to have ensured that these AGVs don't collision with each other. And we want to ensure that there are no deadlocks or timing issues. Okay. Going a little bit deeper into the remote access I was talking about, and my previous speaker just said he has problems to find applications in industry. One of the problems I typically find when talking about 5G applications is that our customer domain is very conservative. So they are used to cables, they are used to shielding. So they hesitate a little bit to come over this approach. One way to argue with them, one way to convince them, because it's more or less just an emotional decision we're facing here, since the technology of 5G is ready when working in the defined parameters, but to convince and to get the customers out of this used to behavior, an easy way to explain it is to say, hey, there is not changing so much. Yeah? We're still using the same bus types, we're still using the same real-time communication. We are still very reliable. We have a low latency. So all you need is there. You just need to step over and have trust in the new technologies. And one way to achieve this is by using Profinet or also other open communication standards. These open communication standards allow us this nice and sweet spot between data transmission rate, amount of devices connected, and also the assurance of the reliability and deterministic. Remote control is often or mostly used there where you have either long distances to bridge, where people need to walk long ways, so that they spend more time with walking or with changing the working place instead of actually performing the job, or where you have an environmental condition which is not very suitable or healthy for the people. The AGV technology consists of a fully integrated, light-weighted solution. Light-weighted, therefore, because the AGV consumes energy, has a battery issue, so you don't want, on default, carry around a lot of weight. You want to be flexible, you want to easily scale them up, so you need a high level of standardization. And again, for deadlocks and transportation systems, you normally also want to have the ability to simulate these effects before you actually put it in place. But these two scenarios I just explained a little bit more briefly, they also have a problem. So when you go more into 5G, when you go more into automation, one problem stays. And this problem is the energy consumption will rise. Yes, you reduce the workload, you reduce the time, you increase proficiency, but what you not do is you don't decrease the energy consumption. Luckily, as of today, we already have enough solutions available to limit this negative impact of more automation. This we do by placing energy measurements visualizing the data, analyzing the data, and with AI technologies, we're also able to predict what options do we have in order to save more energy, which will not only affect the costs on the operator side, but also have the operator, and you maybe remember this little terminal which is in a gangway. The people need to run quite fast to the next spot coming from the automobile. There we have the final assembly line. Where the car housing gets transported through and you have robot arms putting the last pieces together. The normal problem you have here is the supply chain, so how to get the parts on time towards the robots because they're fixed. So the solution in this scenario was that you have AGVs with a kind of intelligence on board. They know how much parts they have covered. They know which process steps lie ahead. They provide the material towards the robot, and once they run out, they automatically go to the home port and place new orders, new parts there. This increases the efficiency of the production tremendously, and it's also easily integratable as long as you already have a wireless network installed. Last but not least, we talked about energy consumption, which would you most likely do with gathering data and transform to some kind of computing, edge or cloud platform. What you also find often in the industry is that you don't have an ideal situation. An ideal situation would be you have a very standardized solution, so you can easily on top put digitalization. But this is not the case in many cases. Customers have different machines, different vendors, different bus types, so you're facing a lot of problems. One way to come over it and still leverage the benefits of data collection is that you integrate an interface or a gateway. This you could, for example, do by an IoT device where you put on the different protocols that then communicates with the different machine types in an assembly line, gathering the data, putting it to the cloud or to an edge computing system, and therefore you can have all the benefits of visualizing, of putting your AI applications on top of it, and on doing predictive things, be it maintenance or providing my wife with further suggestions what to buy. Thank you very much.
Thanks very much. Thank you very much. Actually, last week I had a presentation on 6G for IEEE, and for digital twin, I used a picture from none other than Siemens, and it was not too different from the first picture you showed. Now, first of all, we have a few minutes that we allow if there are any questions to be asked from our distinguished speakers. You know, we had a good lineup from the government. We had a good view of development as well as plans, but in a global context, and also GSMA with those guiding principles. If there is a question, please go ahead and ask. Please.
Okay, I have a question for Mr. David. Many thanks for your valuable user case for 5G and empowering the IoT industry. My question is, do you think there's still some challenge for 5G to integrate it into the industry scenario in a large scale?
Yeah, thank you for your question. Actually, I do think there is still a big challenge left. As I was referring to, customers in the industry adjust to this new technology, to 5G in the industry, the more you will have a lawine effect. So more and more people would join because they heard somebody is doing it, somebody's doing it. But yet we are not on this point where this is really happening. So it's a very intense and effort intense dialogues with the customer to convince them that this new technology is as stable as the one they're used to.
Okay, thank you. I think your answer is we need to prove to the customer the new technology like 5G can benefit a lot to them, and then they have the motivation to use this.
I think many see the benefits already. That's why they're also very interested in it. I think there's a little bit of fear. Yeah? Again, people who grew up and are maybe my age, they are used to cable, shielding, they learned all these interferences, and somehow 5G comes with them with the impression of it's not stable in my environment. It's not reliable. It's not fast enough. Yeah? I have many communication errors. I have production stops. This is the fear you need to overcome. From the potential, from the challenge-wise, I think there we're doing good.
Okay, thank you. So 5G need to prove their stable and safe and all the things they.
Exactly.
Okay, thank you. Thank you very much.
Thank you for that question and great insights and answer. Thank you. Any other one? One more chance? Yes, please, Dr. Tang.
I actually have two questions. I think one, just a follow-up on Madam Wang regarding the industry adoption of 5G. Maybe again to ask Siemens, David. The question is more of how important you felt private 5G totally isolated from the internet and the public network. How important is that a determining factor for the industry, like Siemens, to adopt it in a more massive way?
Okay, thank you for the question. Let me answer in two steps. As a first step, I would say 5G in general is becoming more important. I think we're already at the point where we see the degree of new factories is not so tremendously rising anymore, which brings us in a situation where we have factories who needs to be modernized. We call this brownfield. So you already have an existing solution and you want to leverage new technologies into it. So you somehow must combine it. And 5G is a very good way helping us to extend working lines, to do more data measurements and so on. So, and this is where I think a big rise will come from, or is already there. Private networks are, in my eyes, in 50% maybe of the customers I talk to, relevant. Because they are very hesitating about their data, and this clear network separation is a security aspect for them, because otherwise they are confronted with a lot of, let me say, other challenges if they want to do more IT-OT integration, and therefore they prefer to keep it isolated and have clear access point there, and also very clear security concept.
Thank you. Thanks very much for the question and the answer. I think we will continue.
I'll just have my follow-on question, sort of related, because if all the big factories, big industrial, we say 50% influence, if they need to have a private network for total isolation, then the question is then you need different frequency spectrum for it, for the dedicated private network. And my second question is more, maybe not to Siemens, but more to the Ericsson, Nokia, and maybe the spectrum planning group on their projection about the requirement of spectrum for 5G and the future 6G. I've seen the presentation showing the increase of traffic and the use cases, but my opinion, maybe you can correct me, is very much based on the traditional consumer-centric type of data usage, like the use case about what you call the use cases, including the gaming, more immersive experience, hologram and so forth. It's still very much consumer-centric. Yeah. So I'm just asking whether you can also now look into whether there's a brand new requirement, if we're talking about industries like Siemens or any other vertical industries that required private 5G to be used within their campus in place of things like Wi-Fi and other connectivity. Would that change, you think, your projection about the spectrum usage going forward? Thank you.
Is that a comment or you need some answers? All right, I think you got the point, but I would like to argue that if you look at this typical 6G breaking through user cases, you can hardly say it is only consumer with these numbers. Otherwise, people will challenge why need so much spectrum just for consumers, right? Yeah.
Good. Ericsson, did you want to add to that briefly? Sorry.
Yes, thank you for the question. And I'd like to add something as the answer. I think for the business, 5G or 6G for the business, it's different with the MT for the consumer. Because the industry or the business application needs the performance in different dimensions of the consumer. I think so far most of the business, the industry application will require very high reliability and also the very low latency. It's not so high requirement for the through that stage. There will be some capacity requirement from the industry or the business applications. So.
Thank you. Thanks very much. That also inspires offline dialogues. We have plenty of time today and tomorrow. Thank you so very much for those questions and answers, and also the great talks and all the guests. Now, two more things before we go for lunch. One, please come back to continue at 1:30. The agenda may say 2:30, but I think we have 1.5 hours at least for a lunch break. So we are going to continue. Correct, Justin? We are going to continue at 1:30, and also those online from different time zones, that's just over 1.5 hours from now, 1:30 Beijing Standard Time. Also, now so with that, we close the morning, except for the people in the room. If you allow me, I would like to invite all the speakers and moderators from today and tomorrow, as well as the distinguished guests in front, to come to the stage for a photograph. Thank you. All the speakers and moderators from today and tomorrow, would you like to join us? Yes, please. Good job. I always use Siemens pictures.
1:30开始啊。
Thank you. Yeah, please join us. Yeah.